Welcome, dear all, in the video lecture series. Today, I am going to discuss how to draw SFD and BMD using Staad Pro, tools like Staad Pro. There are many methods of analysis. We can analyze the determinate as well as indeterminate structure using various methods like slope deflection method, moment distribution method, stiffness method, flexibility method. And in the analysis, final output is SFD and BMD, and based on the your bending moment values and shear force value, further we can go for the design of a structure. But before designing, it is required to draw a proper SFD and BMD of the structure. Let me share one screen in which example is solved using moment distribution method, and we will use this as a reference to cross check whether we are getting the correct solution from this TAD or not. So let me share the screen. So if you see, this is the example of a continuous beam in which two spans are there. First span AB of 4 meter length and BC is again due to point load, it is divided into two parts. First part is of length 2 meter and second part is length 3 meter. It is solved using the moment distribution method, and after solving, we are getting this. You can see this. I'm highlighting this part. It is the final SFD and BMD. Okay, SFD and BMD of this continuous beam. So let us start modeling in Staad Pro. Let me share the screen. So we will going to start Staad Pro V8i, which is a student version available free of cost for all the students. So let us start. Initially, we have to choose space structure. We have to name properly to our file. For example, we are giving name to the analysis and design of analysis only, not design, analysis of continuous beam. Let me give the path. Okay. Initially, we have to choose the length and the unit of a length and force. As per our syllabus, we are using SI unit system in which length is in meter and load is kilometer is chosen over here. If we are using some different unit, so accordingly we can select the length of unit of a length and a unit of a force. So next. Finish. So we are getting our platform is ready for our work. It is the initial interface in which grid is there, and each part is divided into uh, grid is horizontally along x-axis 10 meter is there, along y-axis it is again 10 meter. So let us start in a, actually I'm not for analysis purpose, I'm not using this grid as a reference. I'm just initially mark the point over here. So it will be easy. And further we are using some other command. I will show later on. So initially at the 0, 0, I'm marking a point and escape, and I will close that grid. So we are getting this point. So select this point. Now we can use this command. You can see this, it is a translation repeat command. We can using this command we can project this point along x-axis as well as along y-axis. So uh, after clicking this, we are getting whether in which direction you want to project that point. So along x-axis I'm projecting it. Let me refer the PDF. So in this PDF you can see that along x-axis, B point is 4 at a distance of 4 meter and C point at a distance of 5 meters. So in a translation repeat command, we are using a link step. So two steps are there. So first step means first point B, it is at a 4 meter distance length. So we can change over here 4 meter, and second point is at a distance of 5 meter. Okay. So link step. Okay. So this basic structure is ready. We can verify this length by click over here. So first beam we get, it is of 4 meter length, and the second beam we are getting, it is of 5 meter length. So this geometry is ready. Then second tab is general. In general, we have to define the cross-sectional property of the material. Actually, in analysis, it is not required the member size and density, but instead, if you are not defining a section, so it will show error. So it is mandatory that we have to assign a property, whether they are and in the results of SMD VMD, we are not taking self-weight into account, so we'll get a pure analysis result at the end. So no issue where what property we are assigning, but it is mandatory to assign the property of a material. So I'm turning on the nodes which are already given, so we can use the command Shift K. While using the Shift K, the points get on. So section database, click on section database. Okay. Now using Indian code, I'm using Indian ISMB 125, just random selection. You can give the cross-sectional property of concrete also. It is not issue that it is required to assign steel property. It is not the case. You can go with the concrete also. But it is readily available, Indian S-shape section, ISMB 125. So I'm using it. Now assigned to view. Assigned to view means this property is assigned to whole section, whole length. Whatever available on the screen, it is automatically get applied. Okay. So next is support conditions. Support, if we refer this PDF in this problem, analysis of continuous beam, A support is a fixed support, B support is a hinge support, and C support is also hinge support. You can see over here. Means A support is fixed support, B support is hinge, and C means we have to add two supports over here. So create, first support is fixed support, so add it. Again create, hinge support is denoted as a pin support over here. Add. Now we are getting two supports, hinge support, fixed support, and hinge support. So fixed support is assigned at point A, assign. Now it is assigned to the A point, then a hinge support assigned to the B point and C point. Now the both supports are assigned. Now next is apply loading. Now next tab is how to apply load. Click on load case detail, add. Load type details, actually we are not dealing with the design. So load type detail, there are many load conditions, but it is better to have none. And load title is load case 1, add. Click on load case 1, add. Member load. Member load means UDL. What we have to apply UDL. It is a 10 kilonewton per meter. So apply 10 kilonewton per meter over here means downward means minus 10 kilonewton per meter. So add it, close. Now this unit, this load is assigned to first part of the beam. So assign. Now it gets assigned. Now second load is point load of 50 kilonewton, which is applied in the BC part. So add member load. Member load is concentrated force of magnitude 50 kilonewton means minus 50. It is downward, so it is minus 50. And distance of 50 kilonewton is 2 meter from point B. So it is, let's give 2 meter. Add, close. So again use cursor to assign. Now it is going out of the screen, so better to scale down this load. So right click, labels, scales, apply immediately. Distance force means UDL, and for decreasing the arrow, we have to increase the scale of point force. Okay, now it is visible. Apply. Okay. Use key shift V so that we get values of it load denoted over here. Now next is analysis and print. Use this button, analysis and print, and add perform analysis. Now next step is to run this model, analyze, run analysis. Go to post processing mode, apply, okay. Now we can see the deflected shape as well as shear force diagram and bending moment diagram. So let me maximize the screen. So click on MZ value, right click over here, labels, scales, apply the BZ value so that it will get clearly visible to us. Apply, okay. Now click on results, view value, beam results, end moment, maximum moment, midpoint moment, annotate. So let me close one things. Beam result, annotate. Okay. Beam result. Some parts of moment get overlap. So annotate. Okay. End, annotate. Okay. Now it is clearly visible. Now we can see that at first point, the negative moment of 2.67 kilonewton means almost 3 kilonewton. So let's check 2.67 and it is 2.4, almost similar. Now at point B, we get negative moment of 35. 34.884 means 35 almost. And in this way, we are getting negative moments. Okay, so it get cross-checked. Now second is shear force diagram. So click on Fy value, close this one. Again, labels, scales, apply immediately. And this one, shear Y, decrease that scale. So we'll get some maximize view of SFD. Again, results, view value, we'll get beam results, shear force at the end, annotate. Okay, close. So 11, we can see that 11.81 shear force, it is 11.9. Then in between 28.19, we get 28 over here. Then 37, the 36.997 means 37. And at the last 12.97 means 13. In this way, we can draw SFD and BMD using Staad. And it will be created within a second. So it will be easy for us to cross check what we have already solved. Thank you.